Hi everyone, this is Benyamin Ahmadnia, the first and corresponding author of the paper entitled The Impact of Filtering Generated Pseudo-Bilingual Text in Low-Resource Neural Machine Translation Enhancement, the case of Persian-Spanish, to be appeared at 5th International Conference on AI in Computational Linguistics Proceedings. Let's start by introduction. A large-scale bilingual training dataset is an essential resource for training neural machine translation systems. Creating high-quality, large-scale bilingual training texts actually require time, financial support, and also professional experts to translate a large amount of text between two natural languages. As a result, actually, many existing large-scale bilingual corpora are limited to specific languages and domains. In contrast, large monolingual corpora are easier than bilingual corpora to obtain, and we can say, although state-of-the-art approaches have generally employed monolingual datasets to generate pseudo-bilingual text, such approaches do not fully exploit the training data with an eye toward the quality of the generated text. Many approaches have thus employed monolingual data for the target language to learn the language model more effectively. However, experiments are primarily on language pairs where the availability of relatively large scale bilingual datasets supports the variety and viability of this approach. Our paper investigates an approach to expanding the training data effectively by first generating pseudo-bilingual text and then filtering out low quality alignments. We rely on a quality estimation based on a back translation approach in order to boost NMT performance through exclusion of low quality language pairs. Actually, generation of pseudo bilingual text leverages back translation followed by a filtering stage applied to the target monolingual text for removal of low quality language pair actually is employed. If a target sentence and its back translation are similar, the synthetic source sentence is deemed appropriate based on its target monolingual sentence and is thus included in the filtered pseudo-bilingual dataset. Since low-quality bilingual sentence degrade NMT performance, the quality of the pseudo-bilingual dataset is essential. So filtering out low-quality synthetic sentences that would otherwise have been included in your generated bilingual text yield a high quality training dataset for low resource language pairs. We evaluate the impact of our approach on Persian-Spanish low resource language pair. We show that although state-of-the-art methods are effective for low resource language pairs, it's more effective to use a filtered pseudo-bilingual dataset as additional training data for low resource scenarios. Now let's talk about our methodology. Our work actually describes the application of a method for filtering a bilingual dataset generated by back translation of a monolingual text under low resource conditions. The resulting dataset is then employed as an additional training corpus. We then bootstrap an attentional NMT model by iterating the filtering process until convergence. This method contains the following steps. Step 1, translating monolingual um, target sentences using a model trained on bilingual corpus in target source direction to produce synthetic source sentences. In this step, we obtain an unfiltered pseudo-bilingual text as an additional to the unfiltered dataset. In step 2, back translation, back translating the synthetic source sentences using a model trained on bilingual corpus in source to target direction to obtain a synthetic target sentence. In step 3, uh, calculating sentence level similarity metric scores using the monolingual target sentences as a reference and the synthetic target sentences as our candidates for translation is gonna be done. In step 4, we sort the monolingual target sentences and their corresponding synthetic source sentences in the descending order of sentence level similarity metric scores and filtering out sentences with low scores. The threshold is determined by the quality translated sentences in the development set. And in step 5, we employ the filtered synthetic source sentences as the source side and the monolingual target sentence as the target side of the pseudo-bilingual dataset. And the result here is referred to as filtered pseudo-bilingual text, which are used as additional training data. Well, after the filtering step, bootstrapping proceeds as follows. Bootstrap A employs a pseudo-bilingual corpus created using the parallel model as additional data to train our NMT system, and Bootstrap B selects the best model on the development set from Bootstrap A and trains its target to source model. Actually, we employ target sentences from the generated bilingual texts that have been filtered out in the previous iteration to train the best model. If there is no improvement over the previous iteration, bootstrapping is terminated. The filtered pseudo-bilingual dataset and translation model are returned as output, and this process is repeated. Even if the monolingual target sentences remain the same, the synthetic source sentences are refreshed, and each iteration will be repeated again. In other words, or in simple words, the translation quality of both the unfiltered and filtered pseudo-bilingual datasets is improved through the bootstrapping process until the termination criterion is set. Well, in our case study, we employ the Tanzil corpus that contains about 67,000 sentence pairs. We splitted these into 60,000 sentence pairs for the training set, 5,000 sentence pairs for the validation set, and about 2,000 sentence pairs for the test set. To perform Persian to Spanish to Persian translation for the part of Persian to Spanish experiment, we employed and sampled an additional 5,389 Spanish monolingual sentences from the genome corpus, and also we sampled about 8,239 Persian monolingual sentences from the same dataset for Spanish to Persian translation. We compared our system to the following baseline system. One is parallel system trained on parallel corpus in both directions that is used to generate bilingual corpus, and unfiltered system trained on a concatenated parallel corpus with all generated bilingual corpora without any filtering. For the implementation, we employed a transformer on top of PyTorch, which uses a 6-layer LSTM encoder decoder and the hidden layer of 1024. The training set uses the training part uses a mini batch of 256 and the stochastic gradient descent with an initial learning rate 0.1. We set the size of word embeddings layer to 512. We also set dropout to 0.1. We used a maximum sentence length of 50 words, and also we set a beam size of 8, and the model continues for 20 epochs in both training and test steps on a single GPU. For evaluation, we adopt the bilingual evaluation understudy or blue metric. We use our 60,000 sentence pairs to train the first parallel models in both directions. Then we used these generated models to create a pseudo-bilingual corpus by translating 5,389 Spanish monolingual sentences. A concatenation of parallel and pseudo-bilingual sentences is then used to train the unfiltered model. The application of this model yields results including all the systems, indicating that the use of all pseudo-bilingual text as an additional dataset reduces the blue scores. These results suggest that unfiltered data contain many incorrect sentence pairs, which lead to reduced NMT accuracy. Here you can see the top section of the table. We construct a parallel baseline NMT system in both directions of employing an available bilingual corpus to obtain our filtered pseudo-bilingual corpus. The bootstrap results, the middle section of the table, and bootstrap, the bottom section of the table, show that the filtered models outperform the baselines in both directions. Overall, we can say the results indicate that by being selective about which sentence pairs to use from the pseudo-bilingual text, translation performance is improved in our low-resource experiments. Well, as a conclusion, the model trained in this work using filtered pseudo-bilingual text as additional dataset yielded better translation performance than the baselines for our case study. We further improved translation performance over the bootstrapping approach. Also, our results suggest that translation accuracy heavily depends on data size as well as data quality. Also, we showed even greater than improvements from the creation of a better pseudo-bilingual corpus. The size of the usable pseudo-bilingual corpus for low-resource language pairs is very small, so which indicates that filtering out very noisy data results in a higher accuracy of the NMT system. Well, thank you all for your attention, and since I'm not able to attend the question answering session, if you have any question related to this work, You can reach me out via this email address, ahmadnia@ucdavis.edu.